Hello students! Welcome to another fun of learning. Welcome to our quarter 4 science lesson, and I'm your grade 10 science teacher, Mrs. Marizoy ISMS. Our lesson for today is about behavior of gases. Gas is a state of matter that has volume, pressure, and temperature, and those are the quantities that we will encounter in today's lesson. Let us define now what are the meaning of those quantities. Let's first define temperature. Temperature is a measure of average kinetic energy of the particles in the object. During this pandemic, every time you enter in every establishment or when you go in a mall, it is required us to get our body temperature. And to get our body temperature, we use thermometer. If the thermometer give us the value of 36.6, it means that 36.6 degrees Celsius is our body temperature. Volume is the amount of space that an object or substance occupies. One of the example of it is when you buy mineral water in a store. When you buy mineral water, which is in 500 millimeter bottle, the volume of the water is 500 millimeter. Next, we have pressure. Pressure is the certain amount of force applied to a certain area. We usually put pressure related to gas when we're using bicycle pump to make sure that we have enough air in our bicycle tire. And for us to know the relationship between all of these quantities, we will investigate the relationship between pressure and volume at constant temperature of gas. And it can be explained using what we call Boyle's Law. In the middle of 1600s, Robert Boyle, who is a natural philosopher, chemist, physicist, and an inventor, studied the relationship between the pressure and the volume confined gas held at constant temperature, and that's what we call Boyle's Law. Boyle's Law states that a fixed amount of ideal gas is kept at a fixed temperature. The pressure and volume are inversely proportional. The relationship between the volume of a given quantity of a gas and its pressure is expressed by Boyle's Law. This law states that volume occupied by a gas is inversely proportional to the pressure if the temperature remains constant. Boyle's law is expressed using the equation P sub 1 times V sub 1 is equal to P sub 2 times V sub 2, where P sub 1 is what we call initial pressure, and V sub 1 is the initial volume, P sub 2 is the final pressure, and V sub 2 is the final or the resulting volume. Let's have an example. First, we have what volume will 500 ml of gas initially at 25 degrees Celsius and 750 millimeter mercury occupy when condition changes to 650 millimeter mercury at the same temperature. Consider that the temperature is constant, therefore we can use the Boyle's Law. Note also that we have given. Those are P sub 1 or the initial pressure is equal to 750 millimeter mercury, V sub 1 which is the initial volume which has the value of 500 ml, V sub 2 which is the final pressure which has the value of 650 millimeter mercury, and we're looking for the final volume. Now, let's use a formula. So the formula of Boyle's Law is P sub 1 times V sub 1 is equal to P sub 2 V sub 2. How can we derive for a formula for us to know the value of V sub 2 or the final volume? So, from the formula, we can interchange the two since it is equal. So, if we're looking for the final volume, so we will interchange the position of the P sub 1 times V sub 1 and P sub 2 times V sub 2. So, we can have P sub 2 times V sub 2 is equal to P sub 1 times V sub 1. And for us to derive the exact formula, if we're looking for the V sub 2 or the final volume, we divide both sides by P sub 2 or the final pressure to cross out the P sub 2 on the left side so that it will the final volume will remain, and for us to have the equation of V sub 2 is equal to P sub 1 times V sub 2 over P sub 2. Now that we already derive for the perfect formula for us to solve the V sub 2 or the final volume, let's now substitute the value. So we have V sub 2 is equal to P sub 1, which is 750 millimeter mercury, times V sub 1, which is the 500 millimeter, over or divide P sub 2, which has the value of 650 millimeter mercury. Then we have the V sub 2 is equal to 750 millimeter mercury times 500 ml, which is the V sub 1, divide the 650 millimeter mercury, which is the V sub 2. Now that we have the value substitute, let's now cross out which has the same unit, which is the, very good, which is the millimeter mercury. We cross out the millimeter mercury, then we multiply 700 to 500 ml, then we divide it to 650. So we have the final answer for V sub 2 or the final volume, which is the 577 ml. Ma'am, why it is ml? It's because we already crossed out the millimeter mercury and ml remains as a unit for final volume. That's why we have the final answer of 577 millimeter. Let's have another example. So we have the sample, what volume will 400 ml of argon gas initially at 30 degrees Celsius and 725 millimeter mercury occupy when condition changes to 650 millimeter at the same temperature? We have the keyword same temperature. That's why we are going to use what we call Boyle's Law. It is the same process. How we can compute the value of final volume using the Boyle's Law formula. Maybe you will ask me, Ma'am, how can I apply it with my daily life? What are the application in my real life scenario? So the application of Boyle's Law in our real life scenario or our real life, in our daily life, we have the first one. When the plunger on a certain syringe is pushed, the pressure increases and the value decreases. The next one is we have, in order to store gas in a small container, gases are highly pressurized, resulting in the reduction of the volume of the gas. And the last one is in a human breathing. The mechanics of human breathing is strictly follows the Boyle's Law. Remember that according to its definition, pressure is inversely proportional to volume. As we all know, the mechanics of breathing or respiration involve two different processes, the inhale and the exhale. When we inhale, the volume of the lungs increases, which in return decreases the pressure inside the lungs compared to outer atmosphere. Boyle's Law is an ideal gas law that tells the relationship between pressure and volume at constant temperature at fixed amount of gas. Now let's move on with our second law, which is the Charle's Law. Jacques Alexander Cecil Charles, which is a French inventor, scientist, mathematician, and violinist, invented what we call Charle's Law. Charle's Law states that the volume of fixed mass of gas is directly proportional to the temperature at constant pressure. Charle's Law states that the Kelvin temperature and the volume of a gas are directly related when there is no change in the pressure of amount of gas. And to convert temperature from degrees Celsius to Kelvin, you add from the value of degrees Celsius, you add 273. A direct relationship is one in which the related properties increase or decrease together. For two different conditions, the ratio of volume, which is the V, to the temperature, which is represented as T, is constant as long as pressure P and number of moles in do not change. We have Charle's Law is expressed using the equation V sub 1 over T sub 1 is equal to V sub 2 over T sub 2, where T sub 1 is the initial temperature, T sub 2 is the final temperature, V sub 1 is the initial volume, V sub 2 is the final volume. Let's have an sample problem. A neon gas at 760 mm mercury has a volume of 12.0 liter and a temperature of 44 degrees Celsius. Now, find the new volume of the gas after the temperature has been increased to 85 degrees Celsius at 760 bar. Now, let's identify what are the given. We have T sub 1 or the initial temperature, which is the 44 degrees Celsius, T sub 2, which is the final temperature, it's 85 degrees Celsius, and V sub 1, which is the initial volume, which is the 12.0 liter, and we're looking for final volume, which is the V sub 2. The first step, using the Charle's Law, we have, since the temperature are given in degrees Celsius, you gonna need to first change them into Kelvin. How you gonna change it? Okay, you will change it if you will add 273 to the value of degrees Celsius. So if we have the value of initial temperature, which is 44 degrees Celsius, we will add 273 to come up with a value of 317 Kelvin, and to have degrees Celsius to Kelvin, which is represented as K. So we have another one, the 85 degrees Celsius or the final temperature, T sub 2, we will convert it into Kelvin. So we add 273 and we come up for 358 Kelvin or K. That we already have the value of temperature as Kelvin. Now we were gonna use the formula of Charle's law. The formula of Charle's law is V sub 1 over T sub 1 is equal to V sub 2 over T sub 2. And we're looking for the final volume. So, for us to know or for us to derive for the formula for the final volume, we do the cross multiplication. So, we do the cross multiplication to come up with the equation of V sub 1 times T sub 2 is equal to V sub 2 times T sub 1. And for us to come up with the perfect formula for us to solve for the final volume using the Boyle's Law equation, we divide both sides by T sub 2 for us to remove the T sub 2 on the left side. So we have V sub 2 is equal to V sub 1, T sub 2 is equal to T sub 1. Using the formula that we already derived from the Charle's law, we have V sub 2 is equal to V sub 1 times T sub 2 over T sub 1. So we have V sub 2 is equal to V sub 1 times T sub 2 over T sub 1. Then we can have substitutes the value, which is the V sub 1 is 12.0 liter multiplied by 358K over 317K. So that those two values of temperature, which is Kelvin, we can divide it, the two, and remove the unit of Kelvin so that the liter or unit of liter will remain. Then we will come up for the perfect value for final volume, which is 13.55 liter. Now that we already know how we can substitute and derive for the perfect value using the Charle's law, maybe you ask me, Ma'am, how can I apply it into my real life situation? Or how do we apply it? So into real life situation, like in hot air balloon. So this hot air balloon is, the working of an hot air balloon is simple as it consists of a bag or an envelope, a basket to carry passenger, and a fuel force like propane. On ignition of the fuel, the air inside the envelope heats up. This air expands as the temperature of the air increases. The volume of the air also increases. The volume of the air also increases, and consequently, the density decreases. This makes the balloon lighter than the atmosphere air surrounding it. Another example is tires of untouched vehicle get deflated during cold freezing days while get inflates in hot summer days. So in this scenario, in cold season, due to low temperature, the air inside the tire gets cooler and they shrink, while in hot days, the air expands with temperature. And that's all for today, students. I hope you learn and enjoy your lesson for today. Till our next lesson, God bless us all.